Technologies is built on nearly 2 decades of expertise in the global water disinfection and treatment market. Atlantium is making waves in the maritime industry by delivering an effective, environmentally friendly, proprietary UV-based ballast water management system, Purestream, so to enhance the waterway biosecurity. And for this presentation, we've got Ytzhak Rozenberg, who is going to be presenting and taking it away.
Thank you very much. My presentation is about ballast water management system on board. What could go wrong? My name is Itzik Rozenberg, and I'm the CTO at Atlantium Technologies. I would like to thank the organizers for giving me this opportunity to share our know-how with the audience. It's not moving, oops. Okay. A few words about our company. We are providing water treatment solutions based on our proprietary UV systems. We have all the support and know-how to deal with complex applications. On the right side, you can see some of the market segments that we are active in. For the maritime industry, we are offering our ballast water management system under the name of Purestream. The unit is under IMO and the US Coast Guard. We have more than 3,000 installations with global market leaders. Of course, we have a global presence with warehouses, service team, sales support, and all of it. Regarding ballast water management system, it's a regulatory need under the International Maritime Organization, IMO, and US Coast Guard. Every ship will need to have a validated ballast water management system. Ship trading to the USA will need to have a US Coast Guard validation approval for their system. The US Coast Guard regulation is stricter than the IMO, and it is the market focused. Only validated ballast water management system is authorized to be used. The validation process is divided into two, based on the technology that is being used for the treatment. The G9 is for a chemical-based solution, like active substance, and G8 is for physical treatment, like UV. There are two stages of treatment: during ballasting, while pumping water to the ballast tank through filtration and disinfection, and while doing the deballasting, is disinfection only, for like the UV-based solutions, or neutralization for chemical-based. License is granted for a specific ballast water system, specifying operational method, equipment, maximum flow rate, lowest water condition, and retention time. So what is the confidence level for ballast water management system to meet the regulated standards? The Global Marine Services Group at SGS conducted commissioning tests for 95 ballast water management systems and found and published its finding on May 2020. So it's a fresh study. 21% failed to meet the D2 performance standard. All of them failed with the organism above 50 micron. 2% failed in organism above the allowed level of organism between 10 and 50 micron, and 6% failed for organism below 10 micron. The ballast water testing is being done during the type approval process while doing a land-based testing of the solution against standard conditions and the real-time evaluation of the solution during the shipboard testing. In addition, commissioning test will be mandatory for 2021, which verification the performance in the installation on vessel. And soon, the port authorities will conduct from time to time testing of the performance of the system for meeting the regulated standards. So what might go wrong? It all links together. I will start with disclaimer. The SGS didn't publish the reasons for failures. The analysis that you will see in this presentation is based on my know-how, based off hundreds and thousands of installations. globally. And the analysis that I will share with you is based for UV-based solution. So the key for success is starting with the robustness of the solution design, integration into the level, peripheral equipment performance, simplified operation, and the strictness of the validation process. I will start with the equipment, with the solution itself, and we'll start with the filter. The goal for the filter is to remove the 50 micron organism and some of the organism between 10 and 50 micron. The filter integrity is essential and important, meaning that no water will leak and bypass the filter media. So it is highly recommended to use a filter with one filtration element to reduce the risk of water bypassing the filter via the sealing. The filter micron size. Nominal filtration level is important. The filtration level actually defines the majority of the size that will be stopped by the filter and will not go through. For example, 40 micron filter means that 95% of the particles or organism will be rejected and 5% will pass. To avoid this hazard, a fine filter element is recommended. We are using in our solution a 20 micron filter. Not all of the shapes of the organism, as you can see on the left lower side, are round and nice like this. Some of them have a long shape that the narrow dimension of the organism might penetrate via the filter, and it is essential to prevent them from passing the filter. The 20 micron performance is next to 100% will be rejected the microorganism above 50 micron, and around 50% of the organism between 10 and 50 will be rejected by the 20 micron filtration. We are using a filter that was designed and optimized to our solution. The material of filter is made from SMO, which is the most resistive material to seawater, different flow rate, and of course, 20 micron filtration. All of it is with enhanced backwash in order to take out the organism and the TSS that was stuck on the filter. Regarding the UV, the UV is the physical treatment for disinfection, mainly targeting the organism between 10 and 50 micron and other microorganisms. Some aspect needs to be taken into account while implementing a UV-based solution. The startup time. It takes about 2 and 5 minutes for the UV to get into full power and deliver the needed energy to kill or inactivate the organism. During that time, water needs to be flowing via the UV system, and this water is not treated and needs to be considered as such. Another parameter that needs to be taken into account is the water clarity to UV, which is the UVT, UV transmittance of the water. It is recommended to use solutions that can enable treat UVT of 45% and below. Our system can treat water from 40% up to 40% UVT, which is considered to be very opaque water. Sensors. The UV dose is not measured directly. So there are a set of sensors that can measure all the dose-related parameters of the UV. The energy of the lamp, the UVT of the water, and the time which is measured by a flow meter. All of those parameters need to be routed to the controller, and by this, the controller will assure that the needed dose is being provided to the water. Our UV system and solution was especially designed for this application based on our vast experience of know-how. We have in-house all capabilities of designing such reactors. We have designed this reactor to meet a very opaque water, as you have seen. 40% is considered to be very opaque. In this model, we have 8 lamps, and you can see how the water is routed around the lamps. Sensors. This is another view of our reactor. You can see here the 8 lamps, the ending of each one of the lamps. We have a sensor that monitors directly the energy of the lamp, the exact energy of the lamp. And we have another sensor that looks at the lamp via a non-water column Both signals represent the exact condition of each one of the lamps and the clarity of the water to UV, which is UVT. This combination, together with the flow meter, gives the controller all those related parameters for assuring that the unit is delivering the exact dose in order to kill the organisms. Different size of the systems in order to meet the different flow rates on the vessel. The validation process. The validation process is well defined. However, challenging the solution within the validation guidelines is recommended, mainly during the land-based testing. During that time, the land-based, the different parameters can be used. For challenging the filter, you can load the water with the maximum specified TSS, and by this you can examine the condition or the ability of the filter to backwash itself. Another aspect, to enrich the organisms in the water with the ones that have long shape in order to see to what extent the filter can prevent those organisms to pass and get into the treated water. Another aspect that can be tested is introducing into the water organisms that are considered or known to be resistive to the treatment process. For UV solutions, you can introduce organisms that are resistive to UV. For chemical-based treatment, you can introduce organisms that are resistive to the chemical treatment. It's important while evaluating the license that the equipment got to see the performance immediately after ballasting and before deballasting. By this, you can assess the ability of the unit to treat the water with one treatment and the regrowth issue that might cause the vessel not meeting the allowed standard. Another aspect that I mentioned is engineering into the vessel. The ballast water is add-on to the existing ballast system that exists on the vessel. The additional piping are actually dead legs that need to be taken into account by draining, washing, and preventing that water to be discharged before the disinfection or the filtration is fully operational. In addition, when connecting it to the existing ballast system, it's important to make sure that the valves that can route the water and bypassing the solution will not leak. And if accidentally opened, there will be some alarm and notification that something is wrong with the process. I will use a few schematics in order to share with you the different, the piping that we are adding to the existing vessel. So this is the vessel, and those are the lines that we are adding in order to implement the ballast water treatment on the vessel. As you can see from this illustration of the engineering process on the 3D scanning, over here, there are the ballast pump. The water is routed via the yellow pipe into the solution and back to the ballast system. So all those pipes, the yellow and the orange, are the pipes that need to be treated or taken into account because the water is standing here is untreated and need to be special care while operating or starting the unit. I will use another schematic in order to illustrate what I mean. Those are the ballast pumps and the general purpose pump, the valves. The red water is untreated water. Over here you can see the filter, the UV, and the outlet pipes to overboard or to the ballast tank. So the red color water in this pipe is unfiltered and it's not UV treated. The yellow is filtered but not UV treated. So this water actually has organisms and shouldn't bypass the UV while it's start on So that water will get into the sampling and cause a failure with the process. Another illustration is water that can leak and bypass the solution. And again, will be captured by the sampling and the vessel will not meet the regulated standard. Operation. It's highly important to make the operation fully automated and very simple in order to prevent human error. This is another aspect of potential failure during the operation of the system or during the inspection of the system. So to sum up, it all links together: the robustness of the solution, integration into the vessel, peripheral equipment performance, simplified operation, and strictness of a validation process. We have implemented all that know-how in our solution in the way that we are integrating our solution into the vessel, and by this we'll make all it can in order to meet the regulated standard, which is very high and very challenging. I would like to thank you all, and I'm open for questions. Over here, you can see the contact names.
Yes, Mr. Ytzhak, we can see still the contact, so I would like to encourage all interested parties to take a screenshot of Atlantium Marine to actually be able to contact Mr. Ytzhak. Am I right?
Yeah, absolutely. Go right ahead and reach out.
Yeah. So anyway, that was an interesting presentation, and basically, as far as I know, we have also some deadlines regarding ballast water management systems to ship owners to install these systems. So anyway, that was informative. That was interesting. Thank you for that. And I think we can go to the questions directly. So the first question to Atlantium Marine from the audience would be following. How does UV-based ballast water management systems installation compares to other types of ballast water management systems in terms of installation time, costs, maintenance, etc.?
For some, if I understand correctly the question, how I compare a UV-based solution to chemical treatment solution. So there is always advantage of using a solution which is a chemical free. By this, you are not being exposed to discharging water with chemicals into the harbor. There is no hazardous material. It's much less complicated, according to my understanding, because you are not dealing with organic in the water, temperature of the water, salinity of the water, hazardous material that is discharged during the process of a chemical treatment like hydrogen. So it's very much easy to implement and operate.
Great.
Okay,
right.
Thank you. Okay, the next question would be clear and simple. Do you work in Florida?
Yes, we are a global company. We have a presence all over, including in the USA. In Florida, for example, we have one of our sales team. So the answer is yes.
Okay, thank you. Actually, working in maritime business, you have to be global indeed.
For sure,
Anyway,
yeah.
could you please tell us what flow of ballast water can your system handle, and how regularly do the back flushing filters need replacing?
Okay, the maximum system that we are currently offer is around 1,500, 1,500 cubic meter per hour with one system. Of course, we can put multiple systems. Regarding the backwash, it all depends on the load. We like to operate it continuously, but again, it depends on the load in the water, and it's activated according to the DP of the filter.
Okay, perfect. Mr. Ytzhak, one more time, actually, for the audience, I would like to encourage you actually to take a screenshot of Atlantium Marine, because I have no doubt, by the way, right now we have huge number of viewers, and I have no doubt that some of them would need actually the facilities by Atlantium Marine. So, Mr. Ytzhak, for you, thanks honestly and a lot for the presentation. That was interesting, and let's see during the forum.
Thank you very much. Yeah, have a great time.
Thanks a lot.
Bye.